Hello everyone, my name is Rafiqul Islam. I'm from Team 6 of QMST 5335. My other team members are Muzaffer Hosen and Ahmed Yaseer. Today we are going to present Project 3, which title is Banking System Modeling with Simio. So in this presentation we will cover system description and problem statement, then data analysis, Simio model. Under Simio model, we will cover design, verification, reference properties and controls, then problems. After that, we will cover Simio experiment, result, and recommendation. Now the banking system description. Here we can see the diagram of banking system. Here is 3 types of customers. And sign-in times are dependent on customer type, and service times at ATM or teller or manager are independent of customer type. Here are the problems. We need to improve the key performance indicators, which is KPI. 2 employees will be hired, and we need to figure out the 2 positions for hiring. Here is the approach we adopted. This is the diagram. First, we imported data to StatFit, then selecting for possible distributions. After that, finding best distribution with parameters, then exporting expression to Simio. After exporting to Simio, the first step is making data table and Simio model, then Simio verification. After that, developing experiments with response and controls, then assign replications, run length, warm up, etc. Then run and observe responses. After that, we need to check if there is any problems. If yes, we will have to return to assign replications. If not, if it is no, then we'll go to observe the S-mode plots. After that, we'll make recommendations. Now the data analysis. We found that among total customers, 27% are type 1 customers, 50% are type 2 customers, and 23% are type 3 customers. We also found that sign-in time distribution of the various type of customers as follows. The sign-in time distribution of type 1 customers was log normal distribution with mean of 3.01 and standard deviation of 9.65 10 to the power minus -2. And the sign-in time distribution of type 2 customers was log normal distribution also with mean of 3.75 and standard deviation of 0.195. And finally, the sign-in time distribution of type 3 customers was log normal distribution as well with the mean of 3.99 and standard deviation of 0.315. We also determined the percentage of each customer type being directed to each service option, like 81%, 19%, and 0% of type 1 customers are directed to ATMs, tellers, and managers respectively, and 25%, 50%, and 25% of type 2 customers are directed to ATMs, tellers, and managers respectively, and finally 0%, 21%, and 79% of type 1 customers are directed to ATMs, tellers, and managers respectively. We have also determined that the best distributions for service time at each service options, like the service time distribution at ATMs or exponential distribution with mean 106, the service time distribution at tellers or exponential distribution with mean 152, and the service time distribution of manager station or exponential distribution with mean 236. Okay, I will stop here. The next portion of the presentation will be continued by my team members. Thank you.
Thank you, Rafiqul. I am Muzaffer Akanda. I am going to present my part of the presentation for QMST Project 3. In my part, I'm going to show our CMU model. If we go to our CMU model, we can see that there is one source and three different type of customer. Where type 1 customer is basic need customer, they are going to ATM and tailors. And for type 2 customer, they are moderate need customer, they are going to all everywhere like ATM, tailor and manager. And for type 3 customer, they are advanced customer, they are going to tailor and manager. In the background, we make data table to put all the associated values. The percentage of various types of customer was put on the data table, and also we put the sign-in time, distribution, and weights of various customers associated with going to ATM, tailor, and manager also in the database. After receiving the service, the customer leaving ATM or tailor or manager to ATM to sync 1, tailor to sync 2, and manager to sync 3. Also, we can see that the type 1, type 2, and type 3 customers are marked as red, green, and blue. So this is our CMU model. For the CMU model verification, we can verify or validate the model through this theoretical value and simulation value. When we compare both value, we can come to a solution for this whether this model is verified or not, validated or not. So we if you see this slide, you can find that there is a red box. On that box we show only for type 1 customer. Basically for this validation we use only type 1 customer, not type 2 or type 3. So in that type of in that red box, you can see that average value and half width value. From these values we came to the key performance indicator like KPI L and W. L is total number in the system and W is the total time in the system. So from this two value we can see that the values are so close. That's why we can say that this model is validated. In the main model, we use log normal distribution for sign-in time and exponential distribution for ATM, teller, and manager. And in previous slide, we already showed the CMU model, and we use that for verification also, except we use exponential distribution in all system. And for this CMU model, the KPI, I mean key performance reference parameters are like time in system, number in the system, ATM waiting time, teller waiting time, and manager waiting time. Reference properties are our key performance indicator. We will take the decision based on the 5 values. Thus, reference are defined in experiment section. And there are 3 controls like sign-in capacity, teller capacity, and manager capacity. Controls are defined in facility view and view in properties, facility view as in properties as we defined over there, and different scenarios control are changing. So we get actually 4 scenario. So the current scenario was 1 sign-in customer, 4 teller, and 2 manager. And scenario 1, 3 sign-in customer, 4 tellers, 2 manager. For scenario C, there is 1 sign-in customer, 4 tellers, 4 manager. And for scenario D, there are 2 sign-in customers, 5 tellers, and 2 manager. And for this simulation, the warm-up time was 36,000 seconds for 500 customer arrival, and run length was 360,000 seconds for 5,000 customer arrival, where the replication was 100. And this is my part of the presentation. Now I am requesting Yaseer Ahmed to present the next part. Thank you very much.
Thank you, Muzaffer. So now I will be presenting the next slides of our presentation. Now I'm gonna present the CMU model and the problems we faced and the solutions. So actually we were asked to make the run length in such a way so that 5,000 customers arrive. But when we run the model and observe the pivot grid, we found that less than 5,000 customers were arriving in the system. It was something about 4,550. So we thought about what can be done. So we decided to increase both the run length and the warm-up length by 10%. And after we increased it to 10%, that means the run length was 400,000 seconds. We found that our desired 5,000 customers were arriving. And we also had some small issues with the expressions, and at first we gave the wrong expression, but we quickly figured out, and there was no error finally. Next, I'm presenting the simulation results. So this is our experiment part. The right section shows our responses, and the middle section shows our controls that will be changing at various scenarios. So from the response, we find that in terms of the time in system and number in system, scenario A gives the lowest value, and that is exactly what we want. And the ATM waiting time, teller waiting time, manager waiting time, those are lowest in some other scenarios like C or D, but time in system and the number in system is more important than that. That's why scenario A is the best. That means hiring 2 employees in the sign-in station is the best scenario. Moreover, we can also tell that after scenario A, scenario C is the second best option for us. Now let's observe the small plots, and the small plots actually gives the minute detail of the overall process. So what we can find is that the black portions shows us the overall range, the blue portions shows us the upper and lower percentiles, and the yellow section shows us the mean and its associated confidence interval. So from this figure we find that scenario A gives the lowest time in system. So that's why from this perspective scenario A is the best. Now let's consider the number in system. We also find that scenario A gives the lowest total number in system. And then for the ATM waiting time, we find that scenario C gives the lowest value. If we observe, we can find that the yellow portion of this scenario C is the lowest among all other portions. If we consider the teller waiting time, we find that scenario D is the lowest, and its range is also very low compared to other scenarios. So we can conclude that scenario D is definitely the best option for teller waiting time. And if we consider the manager waiting time, we see that everything, the mean, upper bound, lower bound, the range of scenario C is the lowest. So now, we found that we can choose different scenarios depending on different KPIs. So what should we finally do? So if we apply common sense, we find that if a customer arrives in a bank, he or she is not concerned about how many times he or she spends in various stations. Rather, he or she is concerned about the total amount of time he or she spends in the system overall. So, considering these options, scenario A is the best, because in this scenario, a customer spends the less total time. Also, the total number of customers is also less in the scenario A. So that's why we recommend that scenario A is the best, and 2 employees should be hired in the sign-in station. So finally, that's the end of our presentation, and we thank Dr. Rinser for amazingly guide us throughout the course, and the course was very helpful for us. We also enjoyed and learned a lot during the project, and thank you so much.